All right, today we're going to be finding the area of basic figures on the coordinate plane. So in our previous video, we were talking about how to find the perimeter of a figure and of an irregular figure. Today we're going to be focusing on area, and area for us is going to be the amount of space inside a flat figure, so a two-dimensional figure. So any type of picture like this. I've given you the basic formulas that we have for squares and triangles and rectangles. For square and rectangle, we're looking for the base of the shape and the height of the shape. And we're going to take that base and that height and we're going to multiply it together. Square has a special formula, which is side squared, because all of the sides are the same length. So we're multiplying this side by itself. But it doesn't work for a rectangle that way. For triangle, we are also looking for the base of the shape and the height of the shape. And the base and the height are the two pieces that make that right angle. Sometimes it'll be the sides of the triangle. Sometimes we have to build that inside, let's say an isosceles triangle or a scalene triangle. But what's happening is when we take the base, height, and multiply it together, we want to divide it by 2 because we only want half of that rectangle, okay? So from here, let's get started. We're going to try to find the area of specific basic figures on the coordinate plane, okay? So we're going to move it up a little bit. So here we have our first shape, okay? And we want to find the area. So how much space is it taking up? So in order to use the actual area formula, we're going to need the base. So I'm going to highlight the base one color. And the height is going to be a different color. Okay, so how tall something is. Now all I have to do is count how many units tall these are, or how many units long. So for JM, it is 1 unit, and for LM, it is 2 units. So using my area formula, I take the base and I'm going to multiply by the height because this is a rectangle. So my base was 1, I'm going to multiply it by 2, and the area for this shape will be 2 units. And because we're talking about the amount of space it's taking up, we are going to always deem that squared. So your area is always in squared units. Okay. Another way you can tackle this type of problem for area is you can actually count how many boxes it takes up, as long as we're not talking about half boxes or parts of boxes inside the coordinate plane. So all I can do is count the boxes inside. Okay. If I do that, there's 1 box, 2 boxes. So that means that the area of this shape is 2 units squared. All right, let's take a look at another one. Again, pause your video so that you can work the problem out on your own, and then you can check back with me when you're done. Okay, in this particular problem, we're looking for the base and we're looking for the height. So it looks like my triangle is upside down, so if I wanted to put it on a flat surface, I can rotate this entire figure. So I'm going to call this part the base of my triangle, and this part the height. Now I'm going to count how many units long each segment is. Here, 2 units, and here we count 1, 2, 3, 4, and 5. Using our area formula, this time it's a triangle, which means if I were to complete the rectangle, this is half of a rectangle. So I'm going to take my base and my height and I'm going to divide it by 2. We always do this for triangles. So my area is going to be 2 times 5, and whatever I get, I'm going to divide it by 2. So let's simplify. 2 times 5 is 10, and 10 divided by 2 is 5. So the area of this figure is 5 units squared. Okay? Another way you can tackle triangles, if you forget your formulas, is you pretend to build that rectangle. Okay, and I'm going to use a different color for you so that you can see what I'm talking about. Okay, let's say that you want to complete the rectangle. Okay, so I'm going to use this green to complete the rectangle. Okay, so as you can see, we have a whole rectangle there. What you can do is you can actually count all of the boxes inside that rectangle and then divide those by 2. Okay, so what we just did is complete the rectangle. And then we're going to count the boxes inside. And we're going to divide whatever we get by 2. And we should get the same thing. So let's try it. Okay, if I completed the rectangle, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 total boxes in this rectangle. But I only want half of that. So I'm going to divide that by 2. So 10 divided by 2 is 5. And that's another method you can use to find the area of a triangle on the coordinate plane. Okay? All right, one last one. This time, we're going back to that square that we saw in our previous video. And remember, when we have a diagonal, we can't just count those units, okay? We have to actually use the distance formula or a variation of the Pythagorean theorem to help us out, okay? So remember, we're going to pretend that there is a triangle, right triangle, that's going to have a base and a height, and we're going to find the length of that side. So this is side SR, or RS, whatever you want to call it. So I'm going to take the square root, and this is using our modified Pythagorean theorem, or our distance formula. Remember, this was base squared plus height squared. And now, the base of that little triangle I built is 1, so 1 squared plus the height, and the height was 5. 1 times itself is 1, 5 times itself is 25. And then 1 plus 25 is 26. Now we have to find the square root of 26. So with your calculator, you're going to take it. Remember, we're using second squared. That gives us a square root symbol. And now we're going to go to 26 equals, and then round to the nearest tenth. So the 0 is the tenths. I look at its neighbor. It's a 9. That means I bumped the 0 up 1. So this is 5.1. So the length of SR is 5.1. That means this guy is 5.1. And because this is a square, we know that this side is also 5.1. And remember, we wanted a base and we wanted a height. So it doesn't matter which part is the base. So I'm going to say that's the base. And this is the height, okay? So let's use our formula. So I'm going to say the area is base times height. And here we have 5.1 times 5.1. So with your calculator, okay, we can do 5.1 times 5.1 is equal to 26.01. If I round that to the nearest tenth, it'll just be 26.0. Because I'm multiplying this number by itself, another technique would be to just say 5.1 to the second power. And that gives us the same result. But it only works when you are multiplying a number by itself. I hope that gave you a little explanation on how to find the area of basic figures. Until next time.